Okay, important thing to remember about distance is that it's not going to ever be a negative value. So if I ask you to find the distance of a line segment, you should never give me a negative value. That having been said, when we're looking for the distance on a number line, we're going to find the difference between the coordinates and take the absolute value of that. So with this picture right here, our distance would be the absolute value of x1 minus x2. And since distance is a positive value, you could also do the absolute value of x2 minus x1, and you'll get the same solution each time. So I'd like for you to copy this number line down. It doesn't have to be as pretty as mine, actually. You could just freehand straight number line going from -6. You could stop at 5 would be fine, and then label the coordinates. In order to find the distance of BE, we would take the absolute value of B, which is -6, minus E, which is 2. So the absolute value of -8, which is a +8. So from B to E has a distance of 8. You can also count 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what is the distance of DE? We would do the same thing. DE is going to equal the absolute value of x1, which is -2, minus x2, which is 2. So DE is going to be the absolute value of -4. So DE is going to equal the absolute value of -4, which is 4. And you can also count 1, 2, 3, 4. Okay, so now I'd like for you to pause the video and tell me what is the distance of AF, and then see if you get the same answer that I do. So you should get AF is 12. If you did not get that, please raise your hand or ask a neighbor. Okay, now what I'd like for you to do is to tape or glue a picture of the coordinate plane onto the left-hand side of your notes over here. And the question is, how do you graph the points 3, -4? So you're going to go, starting at the origin, you're going to go to the right 3 spaces. X value represents right and left, and then the Y value represents up and down. So since it's negative, we're going to go down -4. So let's go ahead and graph and label the following points. A is 3, -4. So we start at the origin and go 1, 2, 3, and then down 4. 1, 2, 3, 4. So this would be A. And then B, we would go left 2, and then up 5. So left 2, 1, 2, and up 5. 1, 2, 3, 4, 5. So this would be B. Okay, now I'm going to show you 2 ways where we can find the distance between A and B. The first way is using Pythagorean theorem. So we would actually create the line segment AB, and then we would turn it into a right triangle, and we would count the length of each side and use the formula for Pythagorean theorem. C squared equals A squared plus B squared, where this would be our C, what we're looking for. So we count horizontal and vertically. This is 1, 2, 3, 4, 5. This has a length of 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just double check that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we would do a squared and b squared are the 5 and the 9, so c squared equals 5 squared plus 9 squared. C squared would equal 5 squared, which is 5 times 5, 25, plus 9 times 9, which is 81. So C squared would equal 106. That's 25 plus 81. And then in order to undo the C squared, just to get C, the length of AB, we would take the square root of both sides. So C equals the square root of 106. The square root of 106, to get the square root, you would press second x squared, 106, and that would be 10.3. We're going to round here. Another way we can find distance is to use the distance formula, which takes the square root of the difference of your x values squared plus the difference of your y values squared. So now let's try to find the distance of CD, segment CD, with these coordinates using the distance formula. So we take the square root of x minus x. It doesn't matter which one you do. You could do negative 5 minus 3 or 3 minus negative 5. So we're going to do 3 minus negative 5 squared plus y minus y, negative 2 minus negative 4 squared. And then this whole chunk will go in your calculator. So you press second square root 3 minus negative 5. So see how we have parentheses here? I always do double parentheses. 3 minus negative 5 parentheses squared plus negative 2 minus negative 4 parentheses squared, and then add one more parentheses. So you should get 8.2, and that's just rounding to the nearest tenths. So now I'd like for you to try using this formula right here, the distance formula, to find the distance of AB with these points. Pause the video and see if you get the same solution as me. Okay, so I got 5.65, which rounds up to 5.7. If you did not get that, it could be something as simple as calculator work, or you're not understanding the formula. So if that's the case, raise your hand. Midpoint formula. The midpoint is a coordinate point on a coordinate plane. It's going to be represented by an x and a y. So the midpoint formula is adding the x values together, dividing by 2, adding the y values together, and dividing by 2. So let's graph and find the coordinates of M, the midpoint of segment ST. If S is negative 6, 3, so we're going to graph x, which is negative 6, 3, and we're going to graph t, which is 1, 0. So this is our x value here and here. These are our y values here and here. So we add our x's together, divide by 2, add our y values together, divide by 2. Negative 6 plus 1 is negative 5, and 3 plus 0 is 3. And negative 5 halves is the same as negative 2.5, and 3 divided by 2 is the same as 1.5. So now you graph negative 2.5 and 1.5. So negative 1, 2.5 is about here, and then up 1.5. So 1.5 is about here. So this point represents M, the midpoint of segment ST, and the reason we want to graph it is to make it visual that this does look like it's in the middle of S and T, which it does. So now I would like for you to try this example here. Graph and find the coordinates of M, the midpoint of AB. for A is 512 and B is negative 48. Pause the video and see if you get what I get. Okay, so you should have gotten the midpoint is 0.5 or 1/2 and 10, and your line segment is going to come a little bit off the graph, but the M, the midpoint, should look like it's in the middle of A and B. Okay, and the last thing that we're going to do is kind of the opposite of the midpoint. It's what do you do if you're given the midpoint and are asked to find the missing endpoint? What we do is what's called the EMO method. So that stands for endpoint, midpoint, other endpoint. And all I want you to do is just write this, and then we'll go over it here in this example. So finding the coordinates of J if K is the midpoint. So as soon as you see this, that you're given the midpoint, you're going to set up the EMO method, where the midpoint, K, goes in the middle. That's what the M stands for. Midpoint is negative 1, 2. And L has coordinates of 3, negative 5. Well, L is going to be the endpoint. So your job is to find the other endpoint. And that means if this is directly in the middle, it's going to be the same distance from negative 1 to 3 as it is from negative 1 to whatever the other endpoint is. So you have to figure out, how does a 3 become a negative 1? Well, a 3 becomes a negative 1. Here's 3. Here's 2. Here's 0. Here's 1. Here's 0. Here's negative 1. So we would subtract 1, 2, 3, 4. So whatever we did to negative 1, we're going to subtract 4 from negative 1. Whatever we did to 3, we're going to do the same to negative 1. We subtracted 4 from 3 to get negative 1. So we're going to subtract 4 from negative 1, and that's going to give us negative 5. Then we need to figure out, how does a negative 5 become a 2? So here's negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2. That's 1, 2, 3, 4, 5, 6, 7. We add 7. So since we added 7 to a negative 5 to get 2, we're going to add 7 to 2 to get 9. So if we graph this, we have our endpoint, our midpoint, negative 1, 2, and our other endpoint. So now it should look like the M is in the middle of our endpoint and our other endpoint. Okay, so I would now like you to try this example. Find the coordinates of G if P is the midpoint. So this time they gave you the midpoint. So you're setting up the EMO method. Endpoint, midpoint, other endpoint. And your job is to figure out, how did the endpoint become a midpoint? And then whatever you did to that, do it again to the midpoint to get the other endpoint. I know this is very challenging, so if you're not sure, please raise your hand.